Next, we have Nadir de Souza Kovacs, who's a senior geologist. Nadir has been at the GSWA since 2011, and her interest is in the evolution of the landscape and how tectonism affects the landforms, particularly the formation of the regolith.
All right, everybody, good afternoon. I'm here to just give you a quick update on the regolith data sets that we do have at the survey and show you how to use them. In this presentation, I separated in two parts. First, I'm going to show you the layers themselves, and I'm going to talk to you a little bit about what we are planning to do and how to map the regolith next. Okay, we have two state layers. The first one is being mentioned in today quite a few times, 100,000 regolith regimes. And we have a 500K layer that shows the regolith in a little bit more detail. First, the regolith regime layers, we construct that using all the layers, all the map surface layers we had, and we did some further interpretation using radiometric images to come up with that layer that is only 3 codes on it, and basically separating the regolith into residual regolith, that's all your dura crusts and your in situ saprolite, and your depositional regolith, your transported materials, and your outcrops, that's called exposed outcrop unit. So the basic way to use this first layer, or any one of them, is to create your own surface geology map. You're doing that, you can use or geophysical image, or you can use an interpret bedrock geology map underneath it. In this particular example, I just made the exposed unit in the regolith layer transparent, and I laid that on top of IBG. So you have your outcrop exposed. So in here, you can see where the outcrops are and which units are outcropping. You also can see here which units are under the transporter regolith and which units are at the surface, are weathered outcrops at the surface. So you can design your exploration campaign a little bit better. The other layer we have is a 500K, and this layer is very detailed. It's 586 unique codes, not only 3. I cannot even take a clip to show you here what it looks like, not even my clip is too big. So the way you will use it, similarly to the other one, you can make a surface map, but in this case, you use this layer when you want more details about which regolith you're dealing with. You want to know not only if it's depositional or residual, but which kind. Is it a calcrete? Is it a ferricrete? Is your depositional stuff alluvial or colluvial? In this example, I used, again, a geology map underneath it, made the X code, that is the exposed regolith, transparent, and you can see which units and which type of regolith is associated with lithological unit. And in here, I put some geochem data on top. And this particular one is vanadium. So you can see where your sampling or your results are related to the regolith. And that's one way to use it. And that's the way that most people use it. But you could use that for environmental studies as well. Now, we map the surface regolith. We have 2 state layers. They will be improved with time as we do other campaigns in other regions. These maps are digital, so they are going to be continually being improved. But we also want to start looking at the regolith in another dimension. We want to look at depth, and we want to separate it, the residual from the depositional, not only at the surface, but at depth as well. So we started planning, and a pilot project here, we use some chip trace samples from the ag department, agriculture department. And these people drilled for water, and they drew straight down. There's no dipping, it's 90 degrees. And they drill until they hit the rock. So they kept all this material for the regolith. So we decided to just put through the high logger and see what we've got. So This is the area we've got these 56 regolith profiles from, and distribute in here. This is the regolith regime maps, and you can more or less have an idea where they are. They're across the wheat belt. So one example, what are we trying to find out? Where is the positional stops and in situ starts? And therefore, we use the high logger data. And in this particular example, you can see here we have this column is the colonite crystallinity, and this column is the bound water in the mineral. So when the colonite crystallinity changes and the bound water decreases, you have a base of the transported layer. If things changing here, indicating a change from one depositional regolith to in situ regolith. We can pick up other stats as well. We are looking at alteration minerals in this regolith material too. Another thing we picked up in this particular one was a paleochannel. And that's been picked up here by the ferric oxide abundance in the minerals. And it's correlating really, really well with the crystallinity and the water bound. So this way, we're trying to come up with a magic number that we could go through many, many chip trays and many, many drill holes and trying to build a layer slowly, bit by bit, of the regolith at depth and separate the transported from the in situ. Another example here is my colleagues Lucy just talked before me and Sarah Jakika. They used passive seismic to map a paleochannel. And this particular example was a subject of one of our webinars and was very well attended. And Sarah explained how they processed this data, and they did a very good job at mapping this paleochannel at the Yanjipan Gascoyne province, where they use a passive seismic and with drill hole data and gravity to create this 3D model of the paleochannel. See, this the surface map. The place is really flat, and you would not see. The particular company, they knew it was there, but they didn't know what it was doing, the geometry, and which way it was doing, turning. So they were able to create this very cool 3D map of the paleochannel. So that's it for me. It's very quick, but I just want you guys to know that use the regolith layers. They're important. That's there for you. Most of you come up to a place, and that's the first thing you're going to get is regolith. And as so many people have said before me, there will be no outcrop there. So you have to try to understand what the regolith is telling you. It's telling you a lot of stuff. And how can you use that with other data sets? So thank you very much, everybody.